Professor Davis, and here we are, your final topics checklist, Module 15, our final module. Two sections in this module, so let's take a look at them. Remember in section 8.2 we took a look at arithmetic sequences. Now we're taking a look at geometric sequences in series. So here's what we want to do. First, we want to be able to simply write the terms of a given geometric sequence. Example 1 helps us with that. And then we want to determine if a sequence is geometric, and we can do that by comparing successive ratios of a given geometric sequence. And if those ratios are all the same, that's how we know the sequence is geometric. And then find a specific term for a geometric sequence. In other words, maybe find the 17th term, that kind of thing. And that's shown in examples 3 and 4. And then a couple other things here in terms of series. First, we want to compute the nth partial sum of the geometric series. Example 5 shows us a very specific formula that's very easy to use that you'll want to know. That helps us find that. And then finally, determine if a given infinite geometric sequence converges or diverges. In other words, does it go on infinitely, or does it get close to a single real number? Example 6 shows us how to do that. So in this section, we want to do exercises 1 through 17 odd in section 8.3. And then finally, our final section, section 8.4 on the binomial theorem. A couple of things we want to do here. First, we want to be able to evaluate a binomial coefficient, such as the one I've written here, 10 choose 4. Now at the end of the screencast, I'll show you how you can do that on your calculator, so you don't have to worry about using Pascal's triangle and that kind of thing, some of those antiquated techniques. And then finally, we want to be able to use the binomial expansion theorem to expand a binomial raised to a power. So if we have a binomial raised to the 5th or 6th power, something like that, excuse me, we want to be able to use the binomial theorem to quickly write the expansion for that. And that's a technique that's very useful for us when we get to differential calculus and the power rule and that kind of thing. So we want to take a look at exercises 1 through 17 odd in that section. So let me take a minute. I'll show you how you can use your calculator to compute this combination 10 choose 4. So let me call my calculator up. So here's what we do. We simply put in the first number, 10, and then hit the math key right below the alpha button, and then go over to the probability menu. That's on the right side, and you see the very third option is for the combination. The more modern way to write a combination is this way that the calculator does, and choose R, NCR for a combination. So I'll just hit the enter key now, and it was the combination 10 choose 4, so I'll hit the 4 button, and then if we go ahead and hit enter now, we see that this binomial coefficient 10 choose 4 is 210. So you can use that built-in operation on your calculator. Like I said, you don't have to worry about Pascal's triangle and that kind of thing. You can simply use your built-in functions on your machine to find those combinations. So that is your topics checklist for Module 15.